Kitchen chemistry, where science sizzles. Hey there, culinary explorers. You need to hear this if you're a food lover. Ever wonder why we cook food? It's more than just following a recipe. It's about understanding the fascinating science happening right on your stovetop. We're talking about the chemical reactions, the physics of heat, the biology of ingredients. Cooking is a delicious experiment, and today, we're putting on our scientist hats. Think of your kitchen as a laboratory. Your ingredients, those are your chemicals ready to transform. Your oven, that's your controlled heat source. And the best part, you get to eat your experiments. So, are you ready to unlock the secrets of taste and texture? Let's dive into the science behind some of our favorite cooking techniques. We'll explore how a little knowledge can make you a more confident and creative cook. Get ready to impress yourself and your taste buds, because things are about to get very interesting in the kitchen. Next up, unlocking flavor secrets. This is gonna blow your mind. The Maillard reaction, unlocking flavor secrets. Let's talk about the Maillard reaction, named after the French chemist Louis-Camille Maillard. This reaction is responsible for that beautiful brown crust on seared steaks, the golden hue of freshly baked bread, and the deep flavor of roasted coffee. Here's the gist. When you heat food above a certain temperature, amino acids, the building blocks of proteins, react with sugars. This creates a complex chain reaction producing hundreds of new flavor and aroma compounds. The result? That irresistible savory umami taste we all crave. Think about the difference between a boiled chicken breast and a pan-seared one. The Maillard reaction is what gives the seared chicken that intense flavor and appealing color. So, next time you're cooking, remember to thank Mr. Maillard for his delicious discovery. Next up is heat's impact. Heat's impact from tender to crisp. Heat is the engine of the cooking process. It transforms the texture of food in amazing ways. But how does it work? Well, heat is energy, and when applied to food it causes molecules to move faster. This movement can break down tissues, making tough cuts of meat tender or evaporate moisture, creating crispy textures. Think about vegetables. Steaming vegetables preserves their color and nutrients because the steam gently cooks them. Roasting, on the other hand, drives off moisture, concentrating flavors and creating caramelized edges. The amount of heat and the cooking time also play crucial roles. Overcooked vegetables become mushy while undercooked meat can be tough. Understanding how heat affects different ingredients is key to achieving your desired results. Next up, perfect eggs every time. Eggs are a breakfast staple, but they can be surprisingly tricky to cook perfectly. The key to mastering eggs lies in understanding the science behind protein coagulation. When you heat an egg, the proteins in the egg white and yolk denature and then coagulate, meaning they change from a liquid to a solid state. The temperature at which this happens determines the final texture of the egg. For a soft-boiled egg, you want the whites to be set, but the yolk still runny, so you cook it at a lower temperature for a shorter time. For a hard-boiled egg, you need a higher temperature and longer cooking time to ensure both the whites and yolk are fully set. It's all about finding that sweet spot. Next up, a delicious symphony of science. I will never look at bread the same way after learning this. Baking bread is a true testament to the power of science in the kitchen. It involves a delicate dance between yeast, flour, water, and heat. Yeast, a single-celled fungus, is the star of the show. When mixed with warm water and sugar, it comes alive and starts feeding on the starches in flour, producing carbon dioxide gas. This gas gets trapped in the dough, causing it to rise. Kneading the dough helps develop gluten, a protein that gives bread its structure and chewiness. As the bread bakes, the heat kills the yeast, sets the gluten, and evaporates excess moisture, resulting in a crusty loaf. From the fermentation process to the gluten development, baking bread is a fascinating example of how science transforms simple ingredients into a culinary masterpiece. Thank you for watching and listening.